everyone. This is fellow on Maths, fellow in the building. So this is the second episode and the second video of this channel. This is the second episode of Mastering Euclidean Geometry with fellow. So as we have spoken in the first video that we have 3 steps of mastering Euclidean geometry. Firstly, you analyze the information. Secondly, you analyze the diagram. Thirdly, you answer the question. Do not skip any of those steps. This is the principle, the main principle of mastering Euclidean geometry. If you skip any of those steps, you're going to have problems when you're answering your questions. So let's get started. In the information they say in the figure, AB is a diameter. So we are doing the same thing, the same way when we were doing it in the first video. So the diameter, what do you know about the diameter? You know that the diameter subtends a 90-degree angle at the circumference of a circle. So you know angle in the semicircle. That's how you construct your reason. This reason, it reasons why you can say D3, for example, is a 90 degrees because AB, it is the diameter that subtends that DE. What else do you know about the diameter? You know that the line coming from the center, actually, but I don't think that is important here because we can't see any line coming from the center to the chord. So I think about the diameter, we are done. So let's continue with our information. CD is a tangent to circle a D. So tangent to circle a D. Tangent, what do you know about the tangent? You know the Tancourt theorem. What else do you know about the tangent? Where you can say you know the tangents from the same point, but in this case we do not have 2 tangents, so we can't be writing reasons that we know that we weren't gonna use because we do not have 2 tangents here. So you can really say you will need the reason of a tangent from the same point. So we can proceed. Then they say EC is parallel to BC. This is very critical information. EC is parallel to DC. You must keep that into consideration. So it tells you that angle C is a 90 degrees. As I specified again in the last video, that if they give you information and you do not see that information in the diagram, you put it in the diagram. So for us here, the angle C is already specified that it is 90 degrees. As you can see here, our C is 90 degrees. So we can proceed. Then they say BAC and BDE are straight lines. BAC and BD are straight lines. What else can you say about straight lines? You can say about straight lines, you can say the reason adjacent angles on a straight line are complementary. Adjacent angles on a straight line, they give up to 180. Well, in the reason you do not put that, but yeah, you have to know why are you saying adjacent angles in a straight line. It means adjacent angles in a straight line, they add up to 180. So we can continue with our diagram analysis. We have already seen the possible reasons that we might use in order for us to find the angles. Now we can try to find the angles. So the first angle that I will go to, actually we use, as the previous video, we use the reasons to find the angles. So let's go with this first reason, angle in the same circle. Angle in the same circle will help us to find which angle. This angle here is a 90 degrees. You see, so you see your information analysis, it corresponds with your diagram analysis. It becomes easy for you to do diagram analysis if you have really did the information analysis. You see, so let's talk about the Tan-Court theorem. When we talk about the Tan-Court theorem, we can see what this is this is our tangent. Is our tangent, and this angle is opposite to this angle, meaning now we can say that D2 will be equal to B because of what? Because of the tangent, not the tangent, the Tan-Court theorem. So you see, we do not see questions here. We are just doing diagram analysis because we might need those angles. We might need those explanations to say yes, yeah. We might need those explanations when we are doing the questions to say J2 is equal to B because of what? The Tan-Court theorem. But yeah, for now it's okay. Then what else do we need? Well, for now, I can see we are good. We are good. Those were the things that we needed to specify for this question. Actually, maybe we'll be leaded to other angles while doing the questions. So let's go to the very first question. So the very first question, it says prove that ACED is a cyclic quadrilateral. So in the previous video, we talked about how to prove a cyclic quad. So now we are proving a cyclic quad again. So proving a cyclic quad, it means we are proving that there's a circle that moves around the edges E, D, A, and C. So we are proving that actually there's a circle here. Well, it's not going to be accurate, but you can see that there might be a circle there. So we are proving that there's a circle there. So what else do we need to do? We need to give three things to find that circle. So there are three routes that we can take. We can use the external angle, of a cyclic quad. You can use opposite angles of a cyclic quad, or you can use angles in the same segment. So let's start with trying to find the external angle of a cyclic quad. So as you can see here, we have a 90 degrees. We also have a 90 degrees. And you know that the external angle of a cyclic quadrilateral is the external angle of a cyclic quadrilateral is equal to the opposite interior angle of a cyclic quadrilateral. So you can already see that we have two 90s, meaning they are equal. So we have already proven that it's a cyclic quad. So 5 marks in the pocket. You see, just for knowing that how to prove these things, how to go there. Yeah, we have did diagram analysis, so you can already see without even thinking too much. We have already proven the question here, just from doing a diagram analysis and knowing which reasons are we supposed to use. So what are we going to do here? We're going to say D3 is, we're going to say D3 is equal to 90 degrees because angle in the semicircle, and we're going to say angle C is equal to 90 degrees because it is given, and we are going to tell them that D3 is equal to C because they are both equal to 90 degrees. And lastly, we are going to tell them that ACED is a cyclic quad because of what? The converse external angle of a cyclic quad. So you see, you are done. 5 marks in the pocket. I don't know how they make it, but 5 marks is already guaranteed. We're now looking at the mark allocation and looking at the proving, because proving questions are known to be the hard questions, but you will say the question is difficult, but the question generally is easier. So let's go to the second question, I guess. So in the second question, they say A2 is equal to D1. Prove that A2 is equal to D1. So I'm not sure in the screen you can see it, but yeah, A2 is equal to D1. So this is our A2 and this is our D1. We're proving that these two things are actually equal. So I've already seen the answer from what we did, the diagram analysis. So firstly, you can say so let's try to do it here. So the first thing that you can say that you let. So here in this question, I'm going to teach you how to solve this kind of questions. So you are going to let D2 to be X. After letting D2 to be X, you're going to say B2 will also be X. Because of what? Because of the turn chord theorem. Remember, we solved it when we were doing diagram analysis. So you see the importance of doing diagram analysis. You just refer from the diagram and you answer the questions. You see, then after doing that, you now know that you have X here and you have X here. Yeah. Then from what? Again, from what do you want? You want A2, right? So you can just say A2 is equal to 180. So what I'm going to do, I'm going to remove these things because we're not going to need them again now. 180 minus 90, which is D3. We are minusing 90 minus X. Why are we minusing 90 and X from 180? Because the sum of angles in a triangle, they add up to 180. So you're just going to say sum of angles in a triangle. So I took it the short way in what I've already transposed. So you can do it from scratch by saying A2 plus 90 plus X, they are equal to 180. You see? So that's how easy it is. Then you are going to get A2 is equal to 90 minus X. You see, because 180 minus 90 is 90 minus X. Then you are going to now try to find what? D1. When we find D1, we're going to say D1 is equal to 180 minus 90, which is D3 again, minus X. Why are we saying so? Because these three angles, they are on what? The same, they are on the same line, so they add up to 180. So we're going to minus this angle, which is 90 degrees, and we're going to minus this D2, which is X. So we're going to get what? We are going to say adjacent angles on a straight line. Then we're going to get D1 is equal to 90 minus X. What did the question say? Prove that A2 is equal to D1. So we have proved. So you say A2 is equal to D1. Why? Because they are both equal to 90 minus X. As easy as that. You see these proving questions, they are not that difficult. We are the ones who make them difficult. So now we can check the last question. Then they say, prove that triangle CDE is an isosceles triangle CED. So let's see triangle CED. Which triangle are we talking about? So we are talking about this triangle over here, CED, which is this triangle over here, is the triangle that we are talking about. So two angles must be equal here. Two angles must be equal. So personally, I would suspect E and D1. I would suspect that they are equal. But let's do it. It is not about suspecting. It is about proving. You have to prove. Some of you guys are going to do law. In law, you give evidence for everything that you do. So we give evidence for everything that we do. We do not assume. So what are we doing here? We can say that because here we have a circle. Now this is a cyclic quad now. So we can say this angle is equal to this angle. Why? Can you see what I'm talking about? Why? Because the external angle of a cyclic quad is equal to the opposite interior angle. So A2, the first thing that you will say A2 is equal to E. So they are both equal to 90 minus X. Why are we saying so? Because the external angle of a cyclic quad. So the thing is, again, when they say prove that this is a cyclic quad, you have to draw a circle there. So the reason for drawing a circle is for you to be able to answer the next coming question that might need you to talk about something about the circle. Because if you didn't draw a circle, it was going to be difficult because you will still think that this quadrilateral is not in the circle. So I can't talk about the external angle of a cyclic quad. Well, now you can talk about the external angle of a cyclic quad because you have proven that this quadrilateral is inside the circle. You see? So yeah, A2 is equal to E is equal to 90 minus X. Then E will be equal to D1. Why? Because they are both equal to 90 minus X. You have proven that E is equal to 90 minus X. You have also proven here that that D1 is equal to 90 minus X. You see, so now we can say that a triangle CDE is an isosceles. Why are we saying so? Because two angles in the triangle are equal. So that's it. We are done with this question. Yeah, we are done with this question. Yeah, that's how you solve Euclidean geometry questions. That's how you solve your Euclidean geometry questions. Hope you guys are good with this question. Yeah, we'll see each other on the next episode of Master Euclidean Geometry with Fellow. This is Fellow on Maths, Fellow in the building. Have a good day.